All right, let's get into this, because it's a story that starts with a frustration I think every single one of us has felt. It's simple, it's soggy, and it's surprisingly important. You know the drill, right? You get your drink, you feel pretty good about the paper straw, and then like 10 minutes in, it's just this useless, mushy pulp. But the answer to that simple question, well, it opens up this whole fascinating story about design, about money, and about how we've been trying to solve our big waste problem in completely the wrong way.
So, how did we end up with a product that is just famously terrible at the one job it has? Well, it turns out the answer isn't that paper was the best idea, not even close. It was just the easiest one.
And you really have to get this distinction, because it's everything. The choice to go with paper wasn't a quest for the perfect material. It was all about what was practical, and you guessed it, what was cheapest for manufacturers who needed to pivot away from plastic, and fast. I mean, just put yourself in their shoes for a second. If you're a company making straws, you don't have to buy a bunch of brand new expensive equipment. You can just tweak your existing machines to roll and glue paper. Plus, the whole supply chain for food-safe paper, it was already huge. So for businesses, paper was just the path of least resistance. It let them wave a big, "we're going green" flag without having to spend a ton of money.
But of course, paper wasn't the only game in town. A whole parade of other contenders showed up. But as we're about to see, every single one of these alternatives had its own fatal flaw, its own Achilles heel.
And this is where you can see the real dilemma. You've got bioplastics like PLA, which feel great just like plastic. The catch? They only break down in these very specific industrial composting facilities. Throw them in the ocean or a landfill, and they're just like plastic. Wood straws were nice and rigid, but a lot of people just could not stand the feeling of wood in their mouth. And pasta straws, they actually worked surprisingly well, but then you've got to worry about gluten allergies. There just wasn't one single magic bullet ready to go. So if it wasn't about which straw worked the best, what was it really about? This gets us to the core reason paper took over. And it turns out, this was never really an engineering problem to begin with. At the end of the day, it all came down to perception. What restaurants and big brands wanted was something that you, the consumer, would instantly look at and think, oh, that's green. Paper just looks earthy and natural. It's a quick, easy visual signal that says, hey, we're doing the right thing, whether the product actually works or not. And this is the real kicker, the ultimate irony. To stop those paper straws from turning to mush in 2 seconds, a lot of them are lined with PFAS-based chemicals. You might know them as forever chemicals. The very stuff we're trying to get rid of. This completely undermines the whole biodegradable thing and kind of exposes the whole situation as a bit of a performance. Okay, so all of this leads to a really radical question. What if we've been trying to solve the wrong problem this whole time? What if the issue isn't really the straw at all? Exactly. Instead of desperately trying to invent some miracle material that can somehow work in our completely broken and inefficient waste system, what if we flip that around? What if we design materials that are made from the very beginning to work perfectly in an intelligent system? We've been trying to jam a square peg in a round hole. And when you put the two approaches side by side, it's just night and day. Right now, we put all the pressure on you, the consumer, with 5, 6, 7 different bins and confusing rules. The smart approach? It just asks you to sort into 2 simple bins, one for biological stuff like food scraps and one for everything else. The smarts aren't in your kitchen, they're built into the processing plant. And here's what that smart system actually looks like. It's this really elegant cascade of simple, proven tech. First, AI cameras scan everything and pull out the big stuff. Then, and this part is so cool, everything goes into a big water slurry where things just separate by density. Some things float, some things sink. Magnets grab steel, currents grab aluminum. Then, all the biological stuff gets turned into clean energy. And the tiny, tiny bit that's left over, it's incinerated to create heat and electricity for the city. It's a beautiful, closed loop. So how do we actually make a system like this happen? Well, the answer is a totally different way of thinking about rules and regulations, one that flips the old way completely on its head. This is the genius of it. We stop playing whack-a-mole. Banning one bad plastic this year, another one next year. Instead, you create a clear set of rules for the good materials. It's just like a building code that tells architects, you're free to design whatever you want, but you have to use these approved, safe materials. And this is how it works. You define a limited, pre-approved list of materials. You basically go to industry and say, go ahead, innovate like crazy, but you have to play in this sandbox. You have to use materials from this approved list. And every single one of those materials is on the list for one reason. It works perfectly with that intelligent sorting system we just talked about. Nothing gets into the system that the system can't handle.
Now, when you hear all this, it just seems like a total no-brainer, right? It's elegant, it's efficient, it actually solves the problem. Which brings up the big, obvious question. If it's this good, why isn't this happening everywhere already? What's the holdup?
Well, you can probably guess. The resistance comes from the big players who have invested billions of dollars in the current messy system. They've got a huge interest in keeping things exactly the way they are. So they lobby politicians, they push for loopholes and exemptions, and they water down any new rules until they're basically useless. It's a classic fight. Simple, elegant logic versus powerful, entrenched interests.
And that really brings us to the final thought here. This whole journey, from a simple soggy straw all the way to a total redesign of our waste system, it leaves us with this one really hopeful question. What if getting to a zero-waste world isn't actually about asking everyone to make constant sacrifices? What if it's simply about having the courage to finally implement a smarter, better design?